We're in section 5.6 today. And we're going to talk about inequalities in triangles. So our opener, we've talked about inequalities in the opener a little bit, just kind of leading in. So we're going to talk about a couple of things that lead into the triangle inequality, and then right at the end we'll talk about the triangle inequality. So the first thing we're going to talk about, and we'll use this in several different ways today, is I'm just going to call it a property. When we write it down, it looks more complicated than it really is. So I'm going to say if A equals B plus C, and C is greater than 0, we're saying C is positive. If we're adding a number to B to get A has to be bigger than B. So this is like saying 7 equals 5 plus 2. So 7 is bigger than 5. If I'm adding something to this number to get this number has to be bigger than this. So that's why we're saying C is positive. If C were 0, then it could be equal. But because we're adding a bigger number, then it has to be positive. Okay? Or not, then it has to be bigger. So we're saying 7 is bigger than 5. That's what this is telling us. We add a number to another number. The number we get has to be bigger than the number we started with. That's all we're saying. So we're going to use this. We're going to use this in a couple of places today. So the first thing we're going to do is talk about exterior angle corollary. And we've talked about corollaries a couple of times. Corollary is just something we can figure out easily from an original theorem. So let me draw a picture so we can remember what an exterior angle was and how we talked about it. It was a little bit ago that we talked about exterior angles. So 1, 2, and 3. Does anyone remember how we said angles 1, 2, and 3 were related? Almost.
The 2 and 3 were the same?
Yes, that was exactly. So the exterior angle theorem says that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. These three had to add up to 180. I think that's what you were thinking, Matt. All three of these added to 180, and these two added to 180. So this has to be the same as these. So we're going to use this idea on these exterior angles. So just looking at this, if the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3, what do we know about the measure of angle 1? It's got to be bigger than angle 2 or angle 3. Because these two added together give us angle 1. So angle 1 is going to be bigger than angle 2 or angle 3. So that's what we're going to say in words, and then we'll write it out. So the corollary says the measure of an exterior angle of a triangle is greater than each say then the measure, just to be precise, the measure of each, and we call these two angles remote interior angles. So what we're saying is the measure of angle 1 greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 3. So that's all this is telling us. Because these two add together to give angle 1 has to be bigger than either of them. Questions there? Not a difficult idea. Hopefully. All right, so let's take a look at a problem, kind of problem that we might see that has to do with this. So here's our triangle. Got a little bit going on with this triangle. And this is 1, this is angle 4, 3, and 2. And we want to know how do angle 1 and angle 4 compare. So we want to figure out what's the relationship between angle 1 and angle 4. What do you think, Clay? Not necessarily. So we want to know, so we're talking about inequality. So we're thinking the bigger than, less than, the same. So you had an idea, Jordan? No? Okay, let's back up one step. What do we know about, first off, let's look at angle 4. How do angle 4 and angle 3 compare? They're congruent because they are vertical angles. Very nice. So angle 4 is congruent to angle 3. And that's because we have vertical angles. How does angle 1 compare to angle 3? What did we just say about the exterior angle? Is it larger or smaller than the remote interior angle? Larger. So the measure of angle 1 is greater than the measure of angle 3 because the exterior angle is, the measure of the exterior angle is larger than the remote interior angles. And since 3 and 4 are the same, what does that tell us about 1 and 4? Measure of angle 1 is larger than the measure of angle 4. So that's what we were looking for. Because these two are vertical angles and they're the same, they have the same measure, angle 1 is bigger than angle 3, so angle 1 has to be bigger than angle 4. So that's the kind of problem you might see that has to do with this exterior angle correlate. Questions there? All right. So this kind of leads to the way that the sides and the angles of triangles are related. So I'm just going to call this next one, we're not going to give it a name. This is just a theorem. And our theorem is going to say, in a triangle, the largest side is across from the largest angle. The smallest side is across from the smallest angle. and the medium side is across from the medium angle. So that's going to be our theorem about how the sides and the angles of triangles are related. And what that has to do with this whole section is about inequality. So let me draw a picture and we'll write this as an inequality. So here's my triangle. I'll call this triangle ABC. So this is saying if BC is greater than BA, if this side is longer than this side, then angle A is larger than angle C. And it goes the other way around also. We could switch it around if, and I guess I should say measure, if the measure of angle A is larger than the measure of angle C, then the side across from angle A, BC, is greater than the side across from angle C. So we can use the sides, or we can use the angles to decide how the angles and the sides are related. We can list them in order. We can decide which is biggest, smallest, which one's medium. So that's what this theorem tells us. So questions on this? It's a very intuitive idea. It makes sense. We think the angle's bigger. Angle's opened up larger. The side that's across from it has to be pretty big to connect those two sides of the race. If the angle is small, then the side across from it has to be small, because it doesn't take much to connect the two sides of the race. So let's take a look at a couple of examples of that. So here's my triangle. And I'll call this triangle ABC again. And we'll say this is 47, this is 62, and this is 55. So which is the largest angle here? Angle C. Angle C is across from the longest side. So it's across from the longest side, so it has to be angle C. Pretty easy. And then we can go the other direction also. We have a triangle like this, and I'll call this 51 degrees, 65 degrees, and 64 degrees. And we want the sides smallest to largest. So we're going to list the sides smallest to largest. So what's going to be our smallest side? AB, the side across from the smallest angle. What's going to be the next one? AC. This is the medium-sized angle, so the medium-sized side is going to be across from that. It's going to be AC. And that leaves our big, largest side is across from the largest angle. That's going to be BC. So pretty easy idea, right? Large side across from the large angle. Small side across from the small angle. Well, this leads us into our big idea our main thing for this chapter, big idea for the chapter, is the triangle inequality. Not the chapter, this section, sorry. Triangle inequality theorem comes up in a lot of different places. It shows up in kind of surprising places, but basically any place where you're talking about how distances, how you compare distances. In space, it comes up a lot in physics, triangle inequality, when you're comparing distances. So it's kind of surprising in the places that it comes up and the way that the triangle inequality gets used. So what we're going to say for the triangle inequality here, the sum. Sum means we're doing what? Adding. The sum of the lengths of any two sides of a triangle, when we add them together, has to be larger than the third side. So if we add up the lengths of any two sides, that has to be bigger than the length of the third side. So let me draw a picture, and we'll write that out kind of in symbols. Call this side 1, side 2, and side 3. What the triangle inequality tells us is that side 1 plus side 2 has to be bigger than side 3. Side 1 plus side 3, triangle inequality says any two sides. So side 1 plus side 3 has to be larger than side 2. And finally, side 2 plus side 3 has to be larger than side 1. We add up any pair of sides, it has to be larger than the side that we leave out. Now the reason that it has to work out that way is, let me draw a picture down here. So if this is one side of a triangle, I'm going to do my sides in colors. If these two sides don't add up to be larger than this third side, they can't connect. They're too short to connect down here. I can't connect those points. They're not long enough. That's what the triangle inequality is saying. If those two sides are too short, I can't make them connect to the other side. And we don't notice it's greater than, not greater than or equal. If the two sides are exactly equal to the third side, then what we have is something like this. So here's my third side, and the other two add up to, I'm going to put them right on top here, exactly the length of the third side. If they're exactly the same length, then when I stretch them out, they just lay flat on top of that third side. So we just get a segment. We get segments just laying on top of each other. There's not enough to make an angle to have a triangle. So, if they're exactly the same, we just have a segment. They end up laying flat on top of that third side. So that's why they have to be greater. We have to have enough room to make an angle so we have a triangle. So the idea is, if we think about the triangle, the idea really is, it makes a lot of sense why it has to work that way. Questions on the triangle inequality? Okay, let's take a look at the kinds of problems that you might be asked to solve using the triangle inequality. So for these first three, we're going to say, can we make a triangle? So we have sides 6, 8, and 13. So we want to know, can we make a triangle? So what we do with these is we just pair up the sides and add them together and see if they're bigger than the side that we leave out. So we're going to say, is 6 plus 8, 6 plus 8 equals 14? That's bigger than 13. Yep. Then we're going to do the other pairs. 6 plus 13 is 19, and that's bigger than 8. And then we do 8 plus 13, 21. That's greater than 6. Yes? So yes, we can make a triangle. Let's look at another set of 3, 9, and 12. So we make these into the sides of could these be the sides of a triangle? So I'll start out and I say 3 plus 9 equals 12. Is 12 greater than 12? No. So we cannot make a triangle here, because if we put the sides 3 and 9 together, we just get a length of 12. So those two would lay flat on top of the segment that was length 12. We can't make a triangle. So looking at these two examples, does anybody see a shortcut? Add the two smallest numbers. If the two smallest numbers are bigger than the bigger number, then it's going to work the other way. It'll work the other way. So going back to what we said at the very beginning, if these two added together are bigger than this, then whatever we get when we add these to the bigger side is definitely going to be bigger than what's left behind. So if we add the two smaller numbers together and it's bigger than the third side, then we're done. As long as it's bigger than the third side. If it's equal or less, then we know that we can make a triangle. If it's bigger, we know we can't. So all we have to do is check the two shorter sides, because anything that we add to the bigger side is definitely going to be bigger than a smaller number, like we talked about at the very beginning. All right, so there's one other kind of problem that you're going to see with the triangle inequality. Let me go back here really quickly. Any questions on those examples? All right. So for this, we have two sides. We know we have a triangle. Two sides of a triangle are 7 and 9. We want to know what are the possible values of the third side. So what we're doing here is we say we know we have a triangle and two sides are 7 and 9. So let me draw a little. So we're going to see what's the smallest piece that would connect that, and then we're going to keep stretching that out. So we're going to make it a little longer and a little longer until finally we barely have a triangle. So we want to know from the smallest size to the largest side, how big can our triangle be? How big can that side be? So let's call the third side, because we don't know what it is. In math we call things x. So call the third side. Call the third side x. So the three sides of our triangle are 7, 9, and x. And we're going to do exactly what we did in the last problem. Add two sides together in pairs and make sure it's bigger than the side that we leave out. So we'll start with this one. We'll say 7 plus 9 is greater than x. So 7 plus 9 is 16 is greater than x. And I'm going to turn that around, and I'm going to say that x has to be smaller than 16. So the biggest possible side of the triangle that we can have is just a tiny, tiny, tiny bit less than 16. Now let's do another side. 7 plus x, another pair, has to be larger than the side we leave out, larger than 9. What do we do to get x by itself here? Subtract 7. So I subtract 7, and I get x is greater than 2. And I'm going to turn this around and say that 2 is less than x. I'm just writing this in the opposite direction. So this tells us that the largest possible side is just smaller than 16. This says that the smallest possible side has to be a little bigger than 2. Now let's check the third possibility, the third pair. 9 plus x has to be greater than 7. So I'm adding these two together. It has to be bigger than the side I leave out. Do the same thing that I did here. Subtract 9. I get x is greater than negative 2. Does it make sense to have a negative side length for my triangle? Doesn't make sense. Our side lengths have to be positive. So this one where I get a negative for my side length, I'm just going to ignore that. Don't even have to worry about it. So I'm just going to say, doesn't make sense to have a negative side length. So what this tells me from these two is that x, the side can be between 2 and 16. And the way we write that in symbols, I just put these two inequalities together. 2 less than x less than 16. That's how we would write it in symbols. So x has to be between 2 and 16. So the smallest side of my triangle is just a tiny bit larger than 2, and then we can connect those two sides. And then when I stretch it out and make it bigger and bigger and bigger, the side length can be just barely smaller than 16, and then we get a triangle. So that third side length can be between 2 and 16. Questions there? So we do these kinds of problems exactly like we did the one before. Just add the two sides together in pairs, and those two have to add up to more than the side that we left out. Okay. Let me give you write your homework. What we're going to do is go over last night's homework, the homework from block day. And then I have just a little triangle inequality activity that we're going to work on in pairs before the end of class. So there's our homework. And the dynamic activity for 5.6.